Hello everyone. Today we are going to be looking at contingency tables. A contingency table is a way which gives us the data which can help in calculate probabilities much faster. We can easily determine conditional probabilities using these tables. The table displays sample values in relation to two different variables that may be dependent or contingent on one another. So let's look at some examples here. The first example, an example which shows the speeding violations of a driver and the cell phone drivers. And this is a fictional data, keep in mind. So what we're doing is we're having this in the last year, we're looking at how many speeding violations were done by drivers and how many did not have any speeding violations in the last year. It is the same set. We're also looking at the cell phones which the drivers were using while driving. So we're going horizontally here. And the drivers who did not use cell phone while driving. So that is the third row over here. So these are the ones which give us the total values. So we'd like to look at find, oh, by the way, this is an extra total over here. Let's remove this little extra total. Okay, now coming back to the problems. It says find the probability that the driver is a cell phone user. So this is the event we're looking at. A driver is a cell phone user. So a cell phone user is basically this one. And we're looking at all drivers who have got violations and who have not got violations. So the answer is 305. Now remember, it's a probability. So probability is the favorable, which is 305 over the total, which is 755. Okay, let's look at the next question. Here the event is the driver had no violation last year. So we're looking at the probability. A driver had no violation last year. No violation here is 685. So 685 over 755. Okay, now let's look at the probability that the driver had no violation last year and, remember, it's the common thing, and he was a cell phone or she was a cell phone user. So driver with no violations, that means no violations here, and a cell phone user, that means we're looking at the intersection of the third column with the second row, which is 280. So the answer here is 280 over 755. Now, the last question, what is the probability that the driver is a cell phone user or a driver had no violations in the last year? So we are looking at union. So cell phone user, let's say this is C and no violation as an N. This is the event I'm using here. So we're looking at probability. It is C union N. Remember, C is being a cell phone user. N is no violations. Now if you remember, the general addition rule is probability of C plus probability of N minus probability C intersection N. So remember, a cell phone user, this is basically probability of C. No violation, probability N here. And then no violation and a cell phone user, we're talking about this probability C intersection N. So we just basically write down all these values we have got. 305 is the probability of cell phone user. So it's 305 over 755 plus the driver had no violations, 685 over 755 minus the no violation and a cell phone user, that's 280 over 755. It's a very simple math. So add and subtract these numbers here. The answer is 710. Okay, the very last example uses the contingency tables and conditional probabilities. Very important for us. So let's read the problem. a ground fault interrupt switch, so that means a GFI, I'm going to say every time now. A GFI switch turns off power to a system in the event of an electrical malfunction. A spa manufacturer currently has 25 spas in stock, and each of the spa is equipped with a single GFI switch. Now, two different companies supply the switches, and some of the switches are defective, as summarized in the contingency table given below. So where we are having is, because remember, there are total 25 switches. So 25, they can be defective or they can be non-defective. So in total, when you add them up, the defective and the non-defective, 18 and 7, it is 25. Now, the switches are coming from two companies. Company 1, C1, Company 2, C2. So Company C1 is giving 15 switches to the spa manufacturer, and Company 2 is giving 10. So the total again is 25. So in this scenario, when you're coming either from the number of defective or non-defective, or coming from what company the switches are, both of them should equal 25 because the base is the same. In other words, the characteristic is the we are looking at these switches. The switches are of different scenarios, looking at two characteristics placed on these big data set of switches. One is what company is making that switch, and the second is whether the switches are defective or non-defective. So the data set is the same, but looking at two different characteristics. So let's read the question here. It says, suppose the testing reveals a defective switch. Now, how likely is that the switch came from company 1? Okay, so the question is, we're already having a defective switch. Suppose it was a defective. Now, how likely is it that coming from company 1? What I have done here, guys, is I have given a detailed solution in my handwritten slides, which is titled Lecture Note Chapter 3, V6 Conditional Table Example. And I have posted it on my D2L shell too. Okay, so let's go ahead and look at this problem. Let me just now look at, just zoom out a little bit more so we have big picture. Yes, okay. So over here, the conditional probabilities. Let me just remove, we do not need this. Okay, so remember, this is conditional probability once again, conditional probability of an event in relation to another event. It is the probability of B occurring given that event A has already happened. Okay, so this example is the one which we are looking at. So I'm just going to remove this was my old slide, so I'm just going to remove this information here. So let's go straight to the problem. A spa manufacturing company, remember, is taking switches. Now there are two characteristics. Where are the switches coming from? Two different companies, C1 and C2, Company 1 and Company 2. Now, the switches, the same switches which have with the spa manufacturer can be defective or it can be non-defective. So in other words, the big sample space, the sample space is 25 switches, guys, for us. So that's where this whole thing is talking about. Okay, now let's create a picture for us, what we are looking at. Okay, so here's the picture, where the whole sample space is 25. I hope that 25, it doesn't seem to, so let's let it be. So all these are 25 switches. Now there are two characteristics. Either this coming from Company 1, which is the green here. Inside every switch is from Company 1 and outside is from Company 2. Now then the other part is these switches can be defective and non-defective. So the red one are the defective. They can come from Company 1, can come from Company 2. So the ones which are inside the red are defective, the ones which are outside are non-defective. So let's say some events here. E is the event that the switch is selected from Company 1, and F is an event is that the switch selected is defective. Okay. Now, Remember, the number of switches in company 1 is 15 and the number of switches which are selected is 7. Let's go back to this little here. Number of switches which are coming from C1 is 15 and number of defective are 7. The question is, what is the probability that the switch which is defective is coming from company 1? Okay, so that's the problem we're looking at. The testing is done, a switch is found to be defective. The question is, what is the probability that this defective switch is from company 1? So in simple words, an event has already happened. That means a switch is already defective. Now the question is whether the probability that the defective switch is from C1. So the answer is 5 over 7. If we just simply use our logic here, no math here at this point, just simple logic. Let me go back to the diagram here for you, the table. It says the switch is already defective. So what's basically going on, guys? What is happening is we are looking at this little sample space. Instead of 25, you're saying, hey, I have already got a defective switch. Okay, this is what I'm saying. I've already got a defective switch. That's what I'm saying here. I say I have a defective switch. Okay. So what is my sample space? Now 7 is my sample space. And now how many switches are coming from company 1? So basically we're looking at 5. So just using that simple logic, what is the probability that a defective switch is coming from company 1 when the switch we know is defective is 5 divided by 7. That's simply logic using it. But suppose if I want to apply the stats which we have learned, the probabilities and stuff. So let's go into that, through that process. Let's go through that here. Okay, I'm going to go stepwise with you guys. Now, probability that a given defective switch is from company 1. So this is my step 1. Step 1 here is that what event happened first? Defective switch. That is the first thing which has happened, is it's a defective switch. That means event F has happened first. What is step 2? Now we would like to know whether the switch which was defective is coming from company 1. That means event E has now taken place. So what is the step E and 2 telling us in terms of conditional probability? That is, F, the defective switch has happened. E, that it is coming from company 1. So we have first of all written down our conditional probability. So if you look in terms of the diagram, F is here, E is here. Okay, this is the defective switch. E, remember F is the defective switch. Is that what we wrote here, guys? Let me just clarify. F is a defective switch, yeah. Okay, so remember my F is defective switch. That happens first. And E is coming from company 1. So now here, so this is my whole sample space. If we apply the theory we have learned, probability of E given F, that is E intersection F and F. So let's go ahead and just now plug in the numbers. So probability E given F. What is probability of F? Defective switch is 7 over 25. Probability it is coming from company 1. When it is defective, it is 5 over 25. So when we plug in the numbers in the formula, we have 5 over 25 divided by 7 over 25. That means 5 over 25, and you flip the 7 over 25. Thus 25 with the 25 cancel off, and you get 5 over 7. So here's the answer. Thank you, guys.